The next question we are going to discuss is maximum value sum by placing three roots. In this question, you will be given a two-dimensional board of size m cross n, so board n, and we need to place three roots in such a way that they should not be in the same row and same column. Okay. So, and we need to maximize the sum at which three roots are placed. So now let's say if we have placed the first rook at index I comma j, then the second and third row should not be placed in the ith row, and they should not be placed in the jth column. Okay, this is the condition, and we need to maximize the value at which these three roots are placed. Now let's take an example. Now let's say if our matrix board was given as something like this, where it is 3 cross 4 size two-dimensional array, minus 3 1 1 1, minus 3 1 minus 3 1, minus 3 2 1 1. Now, whenever we want to place the first rook in ith row, we will be having, let's say this is R cross C matrix. Then if we want to place a rook, first rook in ith row, then we will have same number of choices to place the first rook. Now we can for this particular row, we can place our first rook at this index or this or this or this. Means we will have C number of choices. Now at the same time, if you want to place second rook, we will have C minus 1 choices, because the first rook is already placed. Whenever we place first rook, let's say if we place the first rook here, then we have to place the second rook either here or here or here, right? So in that case, we will have same number of choices. Now, if you want to place third rook, then we will be having C minus 2 choices. It means if we place the first rook here and second rook here, then we have to either place this third rook at this value or this value. So it will have same number of choices. And as we are maximizing the places at which these three rooks are placed, and we always try to place, it means we always try to place this first rook at the maximum, at the index at which the value is maximum, and we place the second rook at a place which it can second maximum, and third rook at index which it has third maximum. For each column, we will choose the maximum value and place the first rook, and we'll choose the second maximum and place the second rook, and we'll choose the third maximum and we'll place the third rook, right, for each of these rows. So, and we will not bother about the remaining C minus 3 column values, because because these values remaining values are smaller than the first three values, right? So we will not bother about these remaining values. So it means as we are placing in the first three maximum values, so, and we are not bothering about the remaining values. If we can somehow track the we keep track of the first three largest values of each row, then our then it can be done, right? So instead of checking for all the values, I am going to check for only top three values of each row. Now, now for this row, now for this particular zeroth row, the top three elements are 1, 1 and 1, which is at index 0, comma 1, 0, comma 2 and 0, comma 3. Now, if I keep track these elements, now the topmost element will be 1. I'm going to keep track of three things. One is the value at which the value and index I and index j. Now, now the maximum value of zeroth row will be 1 and it is at zeroth row and first column, and second maximum will be 1, which is same zeroth row and second column, and third will be 1, zeroth row and third column. Now I will do this for all rows. Now for second row, the maximum value is 1 again, and it is at first row, first column. Now the second maximum is again 1, which is at 1, value 1, and it is at first row and third column. And the third maximum is these two are same, so I keep track of the smallest index. Now minus 3, first row and zeroth column. And for the next row, for second row, the maximum value is 2, and 2 is at second row, first column, and the next maximum is 1, which is at second row and second column, and third is at and third is again 1, which is at second row, third column. So these are the top three elements of first zeroth row. These are the top three elements of first row. These are the top three elements of second. So I have stored all the top three values of each row. Now, now if I choose this particular element, now let's say if I choose to place the first element, first row. Now if I want to place the first row at this particular element at 0, comma 1, then the second row should not be in zeroth row and first column, right? So I'm going to check for the remaining values to place second row where we will have, and I'm again going to check. Now see, now if I try to fix this value, and if I trying to fix this value, now for this, now for choosing first row, we will have the entire choices as this entire size, right? Let's say this is as answer array. Now the size will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Now to place first row, I will have 9 number of choices. Okay. Now let's say I have placed the first row here. Then to choose second row, I will have this second row will have 8 number of choices, right? And third row will have 7 number of choices. Now if I fix this value, I'm going to check what could be the second. I'm going to iterate over this entire result answer matrix. I'm going to check what are the possible ways to place. And now let's say if I fix this as the second row, then to check the third to place third row, I will have this entire number of choices. Okay, so it means I'm going to use three nested for loop and check all possible combinations to place three roots. Okay. Now, my first inner for loop, like outermost for loop, will start at 0, index 0, and go for this entire length. And the next loop will start from I plus 1. Let's say if I call it as jth loop, and this jth loop will start from I plus 1 and go till this entire size. And my third inner loop will start at j plus 1th index and go till this entire length. And we'll check every possible combination and whatever the maximum value, I'm going to return the maximum. No, now let's say I choose to place the first row at and the value is 1, and let's say the indexes will be x1 and y1. Let's say now I have tried to place second row at uh, the value which has value 2 and x2 and y2 indexes. And now if I choose to place third row at which has value 3 and which has value x3 and y3. Now as we need to place these three rooks in a different row and different column, it means can I say this can I say, this x1 this x1 should not be equal to this x2 and this x3, and at the same time this x2 again should not be equal to this x3. It means my x1 should not be equal to x2 and my x1 should not be equal to x3 and x2 should not be equal to x3. It means these three rooks should be placed in a different row. Now at the same time, these three rooks should be placed in a different column, right? And now if I place this first rook in a y1 indexes and y1 should not be equal to y2, and at the same time this should not be equal to y3, and at the same time this y2 should not be equal to y3, and y1 should not be equal to y2 and y1 should not be equal to y3 and y2 should not be equal to y3. Now, if these six conditions are satisfied, then it means three groups are in a different row and different class. In that case, and we will take a current variable and I'm going to add v1 plus v2 plus v3. And I'm going to return the maximum of this current value and maximum value. maxi, where I'm going to maintain a maxi variable globally, and I'm going to update this maxi variable with this current one. Okay. Yeah, I think this was making sense. Now, if I talk about this pseudocode, let's say if we're given a solve function where we're asking to return a long value, and we were given a 2D vector of integers, which is, let's say, b. Now, and let's say if they have passed number of rows int r and int c, means number of rows and number of columns, we are going to first, we need a 2D vector to store this values and indexes, right? To store value I and j, right? So I'm going to initialize a vector, 2D vector of integer, let's say answer. Now, I'm going to iterate over this entire row, the entire rows, and I'm going to pick the top 3 elements of each row. Now, for int I 0, I less than r, I plus plus, I'm going to iterate over j0, j less than c, and j plus plus. I'm going to iterate over this entire column for each row. Now I'm going to pick the top 3 elements. I have to pick top 3 elements, right? But to do that, I'm going to maintain a vector, 2-dimensional vector. Again, let's say temp. Now I'm going to add, now I'm going to push the value. Value is nothing but board of I comma j. And I'm going to push index I and index j into my temp vector. And from this temp vector, I'm going to take top 3 values. So top 3 values. So to do that, have to sort the values, right? So temp vector. So I'm going to sort this temp dot begin to temp dot end. I'm going to sort it based on, and this sorting is based on first value, which is b of I comma j. Okay. So we have to use custom sorting. So I'm leaving up to you. So after sorting, I'm going to add the top 3 elements into my answer. So and this has to be sorted in decreasing order of the values. I'm going to add answer dot add push underscore back temp 0, which contains the maximum value. I'm going to push temp of 1, which contains second maximum value. At the same time, pb temp of 2, which contains the third maximum values. Now my answer vector will contain all these values. Now, the thing I have to do is I have to iterate over this resultant array and check all possible values. So I'm going to maintain answer variable to store the maximum answer So I'm going to initialize this as the long dot max value. Now I'm again going to uh, yeah, now I'm going to check all possible values. So I'm going to iterate from I0, I less than result dot answer dot length or answer dot size and I plus plus. Now the first value I'm going to pick will be my V1 will be result of sorry answer of I0, which is the value. My answer of I comma 0 will be the value, right? Then answer of uh, I comma 1 will be my index I, and next it will be index j. So I'm going to name it as x1. So answer of I comma 1 will be my index I, and y2 as answer of I comma 2, which is my value j. Now for each of these values, I have to iterate over the remaining elements. Now int j will start from I plus 1 index and j less than answer dot size j plus plus. I'm going to take v2 where as the answer of I j0 and x2 as answer of j1 and x2 as answer of j and 2. Again, I'm going to iterate inner loop k, which is initialized as j plus 1 and k less than answer dot size and k plus plus. Now, and take this v3 as answer of k comma 0 and x2 as answer of k1 and y sorry this is x3 and y3 as answer of k2. Now I have took all three possible combinations, right? And I'm just have to check whether these x1 and x2 and x3 are different, and this y2 and sorry this is y2, this is y2, right? Check whether this y2 y sorry this should be y1 and this y1 y2 and y3 should be different. So if my x1 is not equal to x2 and x1 is not equal to x3 and x2 is not equal to x3 and y1 is not equal to y2 and y1 is not equal to y3 and y2 is not equal to y3. If these conditions are satisfied, then I am going to take the current sum as v1 plus v2 plus v3, and I'm going to, so let's say this as a max value because the answer is a vector. So I'm going to update my maxi. So maxi will be maximum of maxi comma current sum. Now, at last I'm going to return the maxi value where I have the maximum sum. Okay. Now, now if I talk about time complexity, Now let's check what will be the size of answer matrix. Now, now size of this answer matrix is 9 right here. Now, if say if we have r number of rows and at each row we are adding three uh, three values into the matrix. So the size of the matrix will be 3 cross r. Okay. Because at every row we are adding top three values. So these top three values are from 0th row, and these three are from first row, and these three are from second row. So from each row we are adding three elements, and if there are r number of rows, then the size of the answer matrix will be 3 cross r. Now, now to uh, now this post loop will iterate r number of times, and for each row this will iterate c number of times. You know, as we are adding each and every element to our temp temp vector, this temp vector will worst case contains size as c. It will contain c number of elements, right? Because we are iterating over the entire column for each row and adding it into a temp vector. So the size of the temp vector will be of size s, size c, and we are sorting this temp vector. To sort this, it will take c log c time. Now, for each time, we are doing this for each of r row, r number of times. Now, this will, so the time complexity will be here c plus, because we are iterating c number of times, plus we are sorting this temp vector which is of size c, then it will be c log c, and we are doing this entire thing for r number of times. So time complexity will be c plus c log c into r, c plus c log c into r, plus now our answer vector is of size 3 cross r, and we are going to iterate over this particular entire answer array, right? Answer matrix. So in worst case, this will iterate over, let's say r cross c as n, let's say this as n, then this will iterate over n number of times, and this inner for loop will iterate n minus 1 number of times, and this inner for loop will iterate n minus 2 number of times. It means it will iterate over n into n minus 1 into n minus 2 number of times. Now this n can be up to 3 into r to 3r minus 1 into 3r minus 2. Now if we remove this minus 1 and minus 2, it will be 3r into 3r into 3r, which is 27 into r cube. The overall time complexity will be c plus c log c into r plus 27 into r cube. Now, as r comma c will be of 10 power 100, can be of to size 100, then we calculate it, it will be 100 plus 100 log 100 into 100 plus 2 power 27 into 100 cube, which is 10 power 6. And this will be, if we remove this as, because this is the greater value, then 10 power 4 log 100. 10 power 4 log 100 plus 27 into 10 power 6, which will get accepted for given constraints. Now, if you talk about space complexity, we are we are using a answer we are using answer matrix which is of size 3 cross r, right? So now again we are using a temporary vector to store elements of each column, but at each row it gets reinitialized, so it can be of size c. Now overall it will be r plus c. Yeah, thank you.